Okay, so any questions on this from yesterday? Anything we need to talk about there? Nope. Okay. Let's look at today's then. You have a half sheet for your notes. It's front and back, so don't tape it in where you can't flip it over because you got to get to the back side. Look at that. You are doing what you're supposed to do. It didn't work out so well. Okay, so today, November 29th. It's almost December. We're getting close. Okay, so remember yesterday we talked about Venn diagrams and contingency tables as two ways to organize information that you can use to calculate a probability. So this we call it a tree diagram because it shows where it's branching out. It's another way of organizing that information. You can use this in place of either of the things that we did yesterday, but if there's something where there's more than two options, tree diagram is going to be your best way to organize the information. Okay? So in all the ones we did yesterday, the person either got the job or didn't, or they were satisfied or dissatisfied. There were just two options for each decision. If there's more than two, the tree diagram is going to be the way to do it. Okay? So we'll look at an example of that in a little bit, but just know it's another way of organizing the information to calculate the probability. So in your example at the top, it talks about drawing marbles out of a bag. Okay? So it says bag A contains 10 marbles, 2 are red, 8 are black. And then bag B contains 12 marbles, 4 are red, and 8 are black. So we see here we show whenever we draw a marble out of bag A, we have two options. It can be red or it can be black. Since the red is 2 out of 10, that's 1/5. So we write the probability of getting that outcome on the line toward that outcome. For the bag A, we have 8 out of 10 are black, so that's 4/5 are black. So we just write the probability for that outcome on that line. Okay? Then when we get to the second bag, the B bag, there are 12 marbles, 4 are red, 8 are black. So for red, that would be 4 out of 12, or 1/3. And then for black would be 8 out of 12, or 2/3. So that's how we get the numbers that go here, is what is the probability of getting a red from bag B? What is the probability of getting a black from bag B? And then we do the same thing for bag B down here for red and black. So you'll notice these probabilities are the same, these are the same. Because for bag B, that's just the probability of getting those choices. Then to get the final probability out here, we're looking at, we want a red and a red. So when it's an and, we multiply. So we just multiply those two options together and we get 1/15. We multiply this number and this number together and we get 2/15. So for each option, you just multiply going out the branches of the tree to get to the probability of this final result. Okay. So maybe it'll make more sense once we do one. I think doing one is helpful. So let's look at example 1. This one says, each morning coffee is prepared for the entire office staff by one of 3 employees, depending on who arrives to work first. Karen arrives first 20% of the time, and Gail and Barry are each first to arrive on half the remaining mornings. So you can see right now, this is one where there are 3 different options of who arrives first. So that tells me tree diagram is going to be the best way to organize this information. So first thing we need to look at is who gets there first. So for that we have 3 options. So I'm going to have 3 branches for this first part of the tree. So I have Karen, I have Gail, and I have Barry. So we see Karen arrives first 20% of the time. So on this line going out toward Karen, we're going to put 0.2 because that's 20%. So that leaves 80% of the time one of these other two people are there first, and it says they arrive first on half the remaining mornings. So this is going to be 0.4 and 0.4. Anytime you're at one of the decisions, so we're deciding who arrives first, all of these probabilities needs to add up to 1. Because these are all the three options that needs to cover 100% of the time. So we're good with that step? Okay. Now we look and we see the probability the coffee is bitter when prepared by Karen is 0.1. So now we're deciding, is the coffee bitter? So we're going to say for this person it's either bitter or not bitter. And that's going to be the case for each person. We're going to decide if it's either bitter or not bitter. So we see for Karen, the probability of it being bitter is 0.1. So on that line going out toward bitter, I'm going to put 0.1. These two options here need to add up to 1 because I need to take care of all of the time that she made coffee. Okay? So if she makes it 10% of the time it's bitter, 90% of the time she makes it, it's not bitter. And it says when it's prepared by Gail and Barry, it's 0.2 and 0.1. So Gail is 0.2 is bitter. So that means Gail not bitter is how much? 0.8. Good. And then for Barry, we have 0.3 is bitter. So his not bitter, 0.7. Good to have you back. Okay, so to get the numbers, what's the probability of Karen making the coffee and it being bitter? We would just multiply 0.2 times 0.1, we would get 0.02. We want the probability Karen made the coffee and it's not bitter, we would do 0.2 times 0.9 and get 0.18. We want Gail to make the coffee and it's bitter, we do 0.4 times 0.2 would be 0.08. Gail not bitter would be 0.4 times 0.8 would be 0.32. And then Barry bitter would be 0.4 times 0.3, 0.12. And then Barry not bitter would be 0.4 times 0.7 or 0.28. Any questions on that part? Getting the numbers in there. Yes, Josh. You could do fractions. Yeah, it's fine. Okay. So part A says, when you arrive to work, what is the probability the coffee is not bitter? So we want to look at all the times it's not bitter. So for not bitter, I'm going to look here, here, and here, and just add those together. Because it could be that Karen made it and it's not bitter, or Gail made it and it's not bitter, or Barry made it not bitter. So if it's an or, we add. So 0.18 plus 0.32 plus 0.28. We get 0.78. That seem okay? Okay, so part B says you arrive one morning and the coffee is bitter. What is the probability that it was prepared by Gail? So we want to know if the coffee is bitter, it's going to be one of these options here. So 0.02 plus 0.08 plus 0.12. So those are all the different times it could be bitter. We want to know how many of these times was it Gail. Well, the Gail in bitter is right here. It's 0.08. So we're looking for this one out of all the times it's bitter. You can just make it 8 out of 22 if you want to do that. We're doing okay with this? Does this make sense? Sort of? Okay, let's look at the back side. Here we're looking at a private college reports these stats. Um, 70% of incoming freshmen attended public school. 75% of public school students who enroll as freshmen will eventually graduate, and 90% of other freshmen eventually graduate. So, first thing we need to decide is what? I think he said it, I just didn't hear it.
I just said what A was.
Oh, yeah, that's true. Got to do that first. So if we were to draw a tree diagram, we need to decide first, when you look at this, we have something about where the freshmen came from, and then we talk about if we know where they came from, did they graduate? So the first thing we need to know is where did they come from, so we can tell where to put these numbers. Okay? So first decision we're going to make is either public school or some other form of education. So they either went to public school or they were homeschooled, private school, some other form of school. So we see that 70% of the incoming freshmen attended public school. So that's going to go on this line for public school, 0.7. So what goes on other? 0.3. And then after we know which ones, our other thing we're concerned about is, are they going to eventually graduate? Okay. So for each one of these, we'll have either graduate or don't graduate. Information up here says 75% of public school students who enroll as a freshman eventually graduate. So for public school, the ones that graduate, that's 75%. So what goes with the don't graduate? 25. Good. And And then our other statement says 90% of other freshmen eventually graduate. So on the other and graduate, we're going to say 90%, 0.9. So then the don't graduate will be 0.1. Then to get the percents out at the end, we just multiply. So 0.7 times 0.75 would be 0.525. And then 0.7 times 0.25 would be 0.175. 0.3 times 0.9 would be 0.27. And 0.3 times 0.1 would be 0.03. I figured something was going on with the walking and the going on. Gotcha. Okay. They'll probably be sending an email if they haven't already. Okay, so we get them with setting up the tree diagram. Any questions on that? Okay, so we want to know what percent of freshmen eventually graduate. So we're going to add together the two options where they eventually graduated. So we're going to do the 0.525 plus 0.27. So 0.795. So again, you want to make sure you're showing where you got that number. So show adding those two things together to show your work. And part B says, what percent of students who graduate from college? So of these people that we just calculated, what percent comes from public high school? So these people right here are the ones that graduated and came from a public high school. So we're going to do this number over that one. So 0.525 over 0.795. Okay. Good? Kind of? Getting a little more clear anyway? Okay, let's look at our last one. This one is very similar to one that's on your problem set. So whenever you're doing your problem set, refer back to this one because it's very much like it. Okay, so here it says, suppose a test for diagnosing a certain serious disease is successful in detecting the disease in 95% of persons infected. But it incorrectly diagnoses 4% of the healthy people as having this serious disease. It is known that 2% of the population actually has this disease. So we need to set up a tree diagram to look at this information. So this is what is known. It is known that 2% has the disease. That's where we're going to start. This is what we know for sure is true. So that's where we begin this process. So we're going to look at, for the population, they either have the disease or they don't have the disease. So that's going to be our first division. When you're looking at these, especially when it's talking about like medical issues and stuff, normally you will do that. They either have the problem or they don't. That's kind of our first division, because whenever we start this, we're testing them for a reason. We think they have it or we think they don't. So this says it is known that 2% has the disease. So the has disease is 2%. Make sure you put 0.02, not 0.2. Because 0.2 is 20%. So 0.02 and 0.98. So once we've got that division done, now we're going to do the diagnostic test. So the test either shows they're positive for the disease or it's negative for the disease. So for each one of these, we're going to have the test is positive or the test is negative. We go back and read this again. We see that 95% of persons infected, it is successful in 95% of those that are infected. So if they have the disease, the test should say they have the disease. So that's the successful. So it's successful 95% of the time, so that's the 0.95. Okay.